Okay, let's get started then. All right, so thank you for coming to my presentation. It's on a subject that's near and dear to my heart, and it's about getting software into production, which is actually something that's way more difficult than people give it credit for, and you could say that it's downright difficult. So my goal at the end of this is to give you ways of getting software into production reliably and quickly, and not make something that continuous delivery, which is sort of this buzzword that gets thrown out a lot, giving actionable steps to make your software releases simpler. So a little bit about me. My name is John Minchuk. I'm a tech lead slash solutions architect on the TVG project. Been a Java developer for 10 years. I worked for a company called Here Maps, which is a very large tech company in Chicago, and I got quite a bit of experience with continuous delivery there. It's a company with hundreds of developers, and their whole organization was moving towards this model because it's a way of getting software out to business users, to users as quickly as possible. And they were all sold on it. I'm sold on it, and so hopefully I can sell you on it. Little known fact about me: I hate release night because it's probably the worst night of the whole life cycle of developing software. Okay, so why is releasing software painful? If you work on a big project, you know that release day is scary. It's unpredictable. It's messy. There's ad hoc scripts people are using to get software out there. Database changes are sometimes done manually. For the most part, companies are at different stages, but a lot of people have a non-repeatable process for getting software into production. They don't have any kind of automation to get things out there. You have developers logging into servers, manually copying artifacts over, and generally doing things by hand. So why is that scary? Deploying software manually in general is dangerous. You have different people at different parts in their career that might have less experience with the system. Some might have more experience with the system than other. And if you're doing it, by hand and clicking the buttons to make all this happen and following the sequence of steps, it's subject to human error. So things tend to go wrong on release night a lot because we leave that up to humans, which is generally not a good way of automating something. So testing, furthermore, testing for the most part, in most projects I've been on, it's a very manual process. It's inefficient, and just like people deploying software manually, it's also dangerous. It's subject to the same constraints that we as humans have putting software out there and testing things manually. You can't count on environments to look the same from one area to the other, so you have all these inconsistencies, and it adds up to quite a bit of pain. So I just thought these were kind of funny. Does any of this sound familiar? If you're on a really big project, there's a lot of ceremony that happens around releasing software. There's often official-looking and very intimidating emails. These big email chains, you have dates on them, things are written in red, it's very scary. You have sign-off meetings that are eerie and have serious tones. You have people saying, arguing over whether or not we're going to release this feature into production, and then basically who's going to accept responsibility for it when it goes wrong. And so you have these very serious meetings about getting a piece of software out into production. So on release night as a developer, for years, working late and working crazy hours has always kind of been a badge of honor. That gets old after a number of years. Have you ever been in a situation where you're staring at your monitor at 2 a.m., desperately trying to get something to work? Nobody likes doing that. Something goes wrong, for a critical feature, and suddenly your thing that was happening on Friday night is now happening on Sunday as well. So you're patching over the weekend, and that also sucks. And people start doing crazy things on releases. I see this all the time. You'll have a junior developer who is responsible for the deployment this time around, and something didn't go right. He knows that the senior developer restarted a server at some point, and you have people with little experience restarting things, messing with things in production, doing crazy things like applying database patches. There's maybe a primary key that was mismatched, and suddenly you have people manually modifying things in production. So it's kind of like when we release software, it's like all bets are off, and it's just a total free-for-all, and it's scary and, in my opinion, just dangerous. Manually patching things, quickly putting fixes in to patch something up and getting it out on release night, that's definitely not good. I've been there before, desperately trying to get software fixed before everybody else wakes up before sunrise. So I've been there, and you might be there too. So what is continuous delivery? It's a solution for this kind of problem. Continuous delivery is not equal to working in production, which a lot of people think it is. It's not. It's not permission to just go and change things, and it's a misconception that I think a lot of upper management type people have. So it's hard to get traction for it, but it is not equal to working in production. It's pretty much the opposite of working in production. So another thing to note, it's a practice, not a tool, and it requires discipline. So you can't just go buy the continuous delivery server. I'm sure there are people who will try and sell you on software solutions like that, but it's something that you have to decide to do, and you have to decide that the way you're programming is the way you're going to do these things, and it's a discipline thing. So it's inspired by a lot of good practices. There's the lean movement, which is getting software to users fast and to your clients fast, and iterating over it because things are moving very fast these days. You need to be able to get software out. You need to get it tested. You need to change on it. It's inspired by agile development, which we're all familiar with, continuous integration, and it's the culmination of a lot of ideas and practices. So in a nutshell, this presentation is basically covering this continuous delivery book, which is my favorite book on the subject. That's the fun thing about continuous delivery. It takes a lot of these high-level concepts around the way you should be doing things in software, or the best ways to do things, and sort of groups them all under one umbrella. So it relies heavily on continuous integration, which we'll go into, test-driven development, which is always a good way to test your software. It's inspired by the practices of lean startup, which is get something out quickly and iterate on it, and it's also heavily inspired by extreme programming, which is basically a very 90s book about how it's like the predecessor to agile practices. So if you look in there, you'll see kind of what agile was. This is one of the founding books behind agile. So it's inspired by all those things. All right, so here's the idea. If somebody comes up with a good idea, how do we get it to users as quickly as possible? Right? That's kind of the end game here. That's what business stakeholders want. That's what developers want. We want to be able to get things out there and iterate over them quickly. So let's break it down. In my opinion, a lot of this is my opinion as well as the opinion of the book, so you can take this with a grain of salt. But in my opinion, it's three key elements to making this happen. You need to automate, build, deploy, test, and release. So essentially, to me, that means creating a single script to deploy software, right? A lot of places will have different ways that developers get software on machines, different ways they get into test environments, and then a whole other process for getting into production. So if you have one script that takes care of this, that's a huge win, and it shouldn't be that difficult to do. Version control everything, and what's fun about this is we all know we should version control our software, but are we version controlling the configurations that we send out in production? Are those going through code reviews? And there's a lot of great new technology out there that's allowing us to not only version control software, but the environment that it runs in. You got Puppet and CF Engine and all these great technologies that are allowing you to very carefully, test what goes out into your production. So we'll go into that more later. And giving yourself a centralized place to implement and monitor this. So it's kind of like a dashboard that's kind of fun to build yourself. There are other solutions for it, but that's essentially called the deployment pipeline. So, traditional release, this is pulled right out of the continuous delivery book. At the big bar on the top is a traditional release cycle. So if, let's say, this time on the bottom here is the course of a month, this is nice and big because you see there's this big pre-alpha release. We do some testing, and now it's made it to alpha. We do bug fixes, add something, change something. It's in beta. We've gone through some serious user acceptance testing, and at the very end, you have this very highly, tested piece of artifact that at the end of your month is, this thing that we're going to put in production. It's gone through a lot of work, and over time, all these little changes and things build up. So the paradigm shift here is this release cycle is big and long. Well, why not break that down into smaller release cycles? So, let's test a couple of small things, deploy them, and get them out there, right? And then test a couple of things, deploy them, and get them out there. Test a couple things, and this can be right into production. It can be right in your continuous integration environment. But the nice thing about that is when you release something into production, because you're doing it more often, the amount of deltas between what's there and what's not, it's pretty small. So if something does go wrong, it's a lot easier and well understood to fix. So that smaller one, to break it down a little bit, there's the commit stage where you compile where you check a piece of code in, it runs some automated testing, it compiles it, makes sure it builds. It's going to do your unit tests, create the artifacts that are going to get pushed out to the servers. Then it can run through the next portion of it, which is automated acceptance testing, and this is what we call a continuous integration server. Well, this is sort of the continuous integration part of it. You can do automated capacity testing. Does it pass, speed requirements and performance requirements, and then manually showcasing and testing, and then releasing it, right? And if you have that automated script, this can all happen really fast. Like, check something in, runs through some automated tests, give it a quick test, and put it into production. More justification. So this is random things. How long does it take to get your ideas into production? Is it weeks? Is it months? Sometimes it can be half a year. It can be biannually. Sometimes big organizations, it can be annually, right? That's a lot of stuff to be going out at one time, and it's risky. Longer release cycles means more deltas on release night. Let's take the risk out of putting something into production by doing it over and over again. You build confidence in your ability to put something into production if you're doing it over and over again. Of course, the sooner we find an issue, the easier and cheaper it is to fix. If you put something into production and it went wrong, well, let's do that early. Or if we caught it from our unit testing that ran during our continuous integration build, you can quickly see those problems. So the idea is people are expensive resources, machines are not. Let's let your developers use their brains and let machines do the automated tasks and mundane tasks of doing the simple testing and getting software into production. All right, I think this is a good quote. In software, when something is painful, the way to reduce the pain is to do it more frequently, not less. So, that's pretty obvious here, and that's kind of the theme of this book. If something is difficult, let's put it, in the forefront, and let's solve that problem and take the hurt out of it. So, step one. This is my recipe for implementing continuous integration or continuous delivery. Step one is automate your deployments. So for me, that and essentially is one script to get a piece of software out, right? Like you can, if you're deploying your things into production-like environments, your test environments should look similar to enough to where you can use one script that's going to get it out into other places. And there's a lot of neat technology out there now, like Vagrant, that you can even use those same scripts to deploy to developer machines, right? So you're just testing this thing over and over again because you have this one script that's going to be used to get all your software out there. And essentially, let's take a version of the software and point it to an environment, right? Like let's take this and put it there. And if that's the case, that means your developers can do it, your product owners can do it, your testers can do it. They don't have to ask developers or waste developers' time saying, we thought this version of the release was in our environment, so can you put this out there for us? They can do it themselves. Means it's repeatable, there's no room for human error, and everything scripted means it's self-documenting. So if you have a deployment script, I'm sure you've all seen these big, long deployment lists that we have when we're putting a piece of software in production. It's like follow these really long set of steps, and there's all these crazy things like checkboxes we have to sign off on and whatever. And that's a very manual process. The script will now become the documentation for how to do that. And if something needs to change in it, it's well understood what that means. And also, automating something is only painful the first time, right? So it does take time to get these things ready, but the benefits you'll save over the long run, I think, are pretty huge. All right, so step two is continuous integration. I'm not sure how familiar everybody is with this, but a lot of people are practicing it. Essentially, it's all devs working in the same branch. Each check-in triggers a build, test, and deployment of the system, right? So essentially, you have a bunch of developers. They're all working in the same branch. Some places they work in different branches. So they're not interfering with each other, but let's change how we think about that, and let's put everybody in the same branch. And if you're going to check something in, it should be small, and you can do it incrementally over time, and we're all working together. So it allows you to have this one thing, this one release candidate in this one place that's going to be used in production. Right now, we'll do things like, a lot of companies will take a version of software and it's in a branch, and they'll keep working on that and then push it into production, and then there's another branch being worked on in production. The idea is not to be working in two places at once. Everything's happening in this one place, and that's a piece of software that's going to be continuously tested and continuously iterated over and continuously pushed out into a production environment. You need a server to watch for commits, which will build it. One caveat of this is any commit that breaks the build should be fixed immediately or rolled back, and there's ways of addressing that. So this is the part where it takes discipline. If you're going to be implementing continuous integration and somebody breaks the build, you need to address that as quickly as possible or roll it back, right? Because if they're checking in often, the thing that broke it should be pretty small and well understood, and you can just turn it off and, hey, everybody can get back to work. So that the software isn't in a broken state for a long time, right? A lot of software, something happens and it stays in a broken state for weeks, and that causes serious issues. So the idea is it's considered working unless this build system can prove it wrong. Continuous integration tips. There's this great article that's very popular. It's called Continuous Integration on $1 a Day, and essentially what that is saying is a team doesn't really need permission to do this, right? If a lot of there's often spare laptops, there's spare machines, there's desktops. All you need is a server that's going to be watching your commits and running the build for you and doing this stuff and automatically deploying that, right? So to me, that's very powerful. That puts a lot of power back in developers' hands. They can really own this, and it doesn't. You don't need something fancy. All you need is to watch your thing, write a cron script or something, and kick off a build anytime code is checked in. Avoid branching. We covered that one. Visibility is important, right? So having a place where people can see this, and if something does go wrong, is important as well. So the deal with the rubber chicken here, and this is kind of like a way people encourage this. So first thing is you have to encourage your team. Well, the team has to buy in to do this, because there's nothing worse than having some process that you're uncomfortable with or you don't think is going to work for your team forced upon you. So if your team is having trouble, it's a popular thing. If your team is having trouble, with broken builds, you can encourage that by, for instance, on an old team of mine, if we broke the build, you'd have to take $1 and you'd have to put it in the coconut head, and you had to march over there in front of everybody, put the $1 in. And at the end of the month, you all went out for drinks using the money from the broken builds. That's one way of doing it. Some people will put a dunce hat. This one was a rubber chicken, had to be on your desk if you did it. I think in this example, they actually hooked the rubber chicken into an alarm system, so the thing would start beeping if the build went off. So I prefer people don't go overboard with this. I don't like shaming people into doing their job. I think just an email is good enough. If something goes wrong, send an email out with the build, send it to the whole team. Hey, this commit broke it. It was attached to this person's name, and usually that's more than enough to get people to buy into that. But that's a good article. It's a popular one for this topic. Okay, so continuous integration, there's two parts. It's the continuous build server, and it's also the testing that goes into it. And so I think we're familiar with quite a bit of these. Unit testing, that's testing the smallest parts of the app. Your build, somebody checks in some code, the build gets kicked off. The unit tests run very quickly. They should be easy to do. Code coverage, integration / component tests. That's if you're deploying your piece of software into an environment. It's going to interact with external pieces. So you can break those into two separate phases. There's the unit testing part of it, which is doing the small, quick, easy things, and then there's the more time-consuming integration tests, which can be kicked off in a separate phase. But those are testing database. If you put something in a database, are you getting back what you expected? When you connect to this REST endpoint, are you getting back what you expected? Ways to do this, if you need, you can use mocks if necessary. There's cool software like Soap UI, which allows you to mock things that exist in these environments. You can mock things in code as well, which is a very popular way of doing that. And ideally, you want to code to an interface to make this easier, and so that's inversion of control. That's the way Spring is founded on. That's coding to an interface, dependency injection, those things. I could do a totally separate talk on that because those are good practices. But if you're doing it that way, it makes unit testing your software very easy to do. You should encourage your developers to use test-driven development, which is write the test first, build the code till it passes. something that I like about test-driven development is me as a tech lead, or formerly as a senior developer. A lot of teams will have their junior developers write unit tests and the testing. That's kind of like me as somebody who's has more experience with the system and former teams. If I write the unit tests, or if I write the integration tests, I'm the one saying how things should be working, and how eventually we're using a senior developer's knowledge of the system and letting the junior developers fill in the gaps. So I personally think that you can get a lot of value out of technical leaders doing what seem like mundane tasks. I mean, oftentimes I end up testing things manually because I need to be absolutely sure that everybody understood it, and oftentimes the testers and the developers miss the point. And so you can get a lot of value out of higher level people doing that sort of seemingly mundane stuff. I want to cover the 80% code coverage recommendations. So this is another one of my opinion warnings. You may differ, and I'd love to have a conversation about it if you do, but 80% code coverage is often recommended. I have almost never seen that happen. There's parts of code that are data transfer object, there's legacy code that still needs to be there for various reasons, and so me personally, I would prefer somebody to write a quality unit test or a quality test than a test that is than trying to meet some metrics. So if I gave somebody an 8-hour day, I would prefer one unit test or one test that came out of that 8 hours of that day that solved the problem well than 8 of them that cover a broad range of cases that are usually not well thought through. So I mean, if when I look at unit tests, and if I go to like a Sonar instance and I look at those unit tests, oftentimes more code coverage is just completely associated with bad unit tests. So I personally don't like to use it as a metric of quality. Funny anecdote, when I was working at Here Maps, we had hundreds of code bases and we had dozens of teams that were working on active projects. Sonar was provided for us as a service, which meant we couldn't comment out what we didn't think was necessary. So it turned into a status competition between management to want to see your code, coverage, right? Everybody wanted theirs at 80%, and they wanted theirs to be the most covered code because it reflected well on them. However, they were doing hacky things to get that code coverage up, like implementing libraries that tested getters and setters on POJOs, which I have no idea what the value of that is, but they were doing it, So, don't let it turn into a competition, in my personal opinion. All right. So manual testing is both prohibitively expensive and rarely good enough on its own to ensure a high quality result. So that's not to say testers don't have their place in this model, but we believe that manually testing something just isn't a good way of getting a result down there. Though people who are manually testing things could be spending more time getting familiar with the system, thinking of good test cases, things that are too difficult to write into unit tests, not doing the same repetitive tasks over and over again every time a piece of software is released into production. So the idea is continuous integration. Write those tests, take the time to write those tests, and so when you're releasing a piece of software, a lot of the manual work is done for you. It allows you to confidently throw something out into production. All right, step 3 is configuration management. Now, this is the cool stuff I was talking about before. You have environments that look different from each other. So test and production, you have people going in there and manually changing things, like somebody had a configuration parameter that they needed to change on an Apache server. It was increasing the memory or doing whatever, and they changed that one thing in the testing environment to make their piece of software work. They know they're going to have to do it in production, but when production time comes around, somebody else did the deployment, and that piece of that detail was totally left out. And to me, it happens all the time, and it botches a lot of deployments, and those issues are very hard to hunt down. So the idea here is if there's all these new tools that allow us to use infrastructure as code, like you write a script that says, here's what my server environment should look like. Here's the libraries it should have on it. Here's the configuration files that should be present on it, right? So it goes through the same scrutiny that your code does. So releasing something into production, you can be fairly confident that what's happening in in production is what you saw in your test environment, and that goes a super long way towards making your deployments more reliable. I like this one. I mean, this isn't always the case, but it should be easier to rebuild an environment from scratch than fix a broken one. If you're using, this infrastructure as code, you can write software or environments that sort of unfold themselves, right? If you can do this at deploy of a button, provision some servers and point them at a script or something like that. Like if something's wrong, waste it because it doesn't look like production anyways. So let's fix that problem. And in most cases, debugging those environment issues is actually a lot of work because you're talking with different teams, you're talking with different developers. Not everybody has access to the logs they need. So the idea is just like, make it easier to get that stuff set up. Yeah, so no more forgotten server changes on release night. That's what we're going for here. So here's some cool technologies that are enabling that. I've been working with Puppet for a very long time, so I'm kind of biased towards it. That's essentially you have a central configuration management server, and it describes the way the environment should be. So a server comes online or an environment comes up. The first thing it does is it talks to the central server and says, hey, what should I have on me? And the configuration management service says, well, you need an Apache instance, you need this library, you need this file, you need some kind of configuration for an S3 bucket, whatever, and you can do it from all in one place. And those scripts can be used through every environment. So it's really cool the way that's working. We have CF Engine. I think that's eventually what TVG is going to be using. I don't have any experience with it. Ansible at TVG for the PE team, Shane has implemented a version of has implemented that for us, and it's awesome. So we experience this problem at TVG right now, which is sort of what brought me here. And we talked about it at TVG, and it raised some interest. Shane has done awesome work, and I believe he's going to be doing a presentation on it in the near future, and so I'm really excited about that. Vagrant is a way of provisioning machines locally on a developer machine. You can, I was on a project where we had trouble. We had trouble writing our software to make it look like production, and I wrote some Vagrant scripts that developers could go. They run a script, boom, it sets up a production-like server right on their machine, and they're throwing software onto it. Like, doesn't get any more convenient than that. CloudFormation, I use that at here. That's basically JSON files that describe what an AWS system should look like. I was working with them like 2 years ago. They're super ugly, and AWS can be expensive if you're provisioning it. I think our company spent like thousands of dollars a month on AWS environments. So I would be wary of using CloudFormation for everything, but Vagrant is a great way around that. Okay, Puppet example. This is something I pulled off a server that I host my websites off of. I built it years ago. Essentially, and if you have superhuman vision, you'll be able to see this. Sorry, it's not bigger. You have your base instance here, like you have a class, and it might say that, you have variables at the top here. You can see this package declaration that says, I need PHP, I need image magic. I have a package called links that I automatically put on all my instances and all my machines. Git is automatically installed on every machine. That's a base package. Up here, this is a regular expression that totally got garbled up. But this one is basically saying include base, right? So if somebody has this in their host name, or they have dev machine in their host name, it's going to say, okay, include base. That means I'm going to get all these packages, include HTTPD, so I put an Apache server on here. I include user, which is going to set up the user accounts that I automatically use to connect to this thing. There's a script here that automatically sets up the domains that I use, HTTP rules, all that stuff, and boom, you just point a server at it, and production-like environment, on a developer machine, on a test environment, in production, whatever. And it's testable. Check this in, and you can test it, you can work with it pretty easily. All right, so part 4. And this is sort of the thing that ties everything together. It's called the deployment pipeline. Deployment pipeline is a central place to access and view information about your environments. It should be big, visible, and loud. So basically, we're talking about a control panel which says, like, what we're after is push-button deployments. You can have a tester, you can have a developer come to it and say, this continuous integration build didn't work. I want to get this So why didn't it work? Let's roll it back. Let's try another version of the software. Let's let it build. If it does its thing, let's promote it to the UAT environment. Let it go through those steps. If that works, and pass it on. What I like about it is it can be kind of like a central place where everybody goes to find out information of your environment. Oftentimes during a release, I find myself asking like, oh, what's the link to that user interface, or what's the thing that what's the status, or what's our code coverage, and it's this like huge collection of links that are sort of all over the place from various people. So the key features: push button deployments, the continuous integration feedback can be put here as well. Tell you about what's deployed and where, and maybe some status of the environments. You can get all kinds of useful information out of this place. To get to this point, though, to me, this is kind of the last step here. It depends on good configuration management. Do your environments look similar? Can you trust it? Do you have your automated deployment set up? Are those tests working well? And you need to be disciplined about using it. If people are still going on to those production servers and manually making changes, you're still going to have the exact same issues that you had before. So it requires discipline to know that this is the only one place where you're going to be doing this. So here's an example of a continuous deployment pipeline. This was pulled right out of the continuous delivery book. You can see you have a version of the software on the left here. And as we go on, you'll see there's a commit phase. Looks like all these builds passed. That's great. The first one at the very bottom, something didn't work with the acceptance tests, right? We went to the acceptance test phase. It connected to a third-party REST point. When we processed that data, something went wrong. Okay, well, clearly that's not going to make its way through the deployment pipeline all the way out to production. Somebody checked in another version of it, probably that same day. It looks like it. And, that one passed. It passed the performance testing. It passed UAT, and then it went on into production. You'll notice that there's a little auto. It says auto between these. So, the commit phase worked. It automatically went to the acceptance. It automatically went to the performance. But until somebody clicks manually deploy, it's not going to go into those elevated environments. So it's not. There's still a level of human interaction here that you're using, but it allows you greater control.
And that's breakpoints are they just to make sure that everything's working correctly?
In this particular example, it automatically goes all the way up to performance, but user acceptance testing, like this is the automated stuff. These are your automated tests. The user acceptance testing is still where you have testers going in there and saying like, okay, this is working the way we think it's supposed to be working, and it's got sign off from people. So this is where your ceremony comes in, I guess, but it's a manual deployment to there, right? Because oftentimes testers are testing things, and you don't want to overwrite what they're working on. So there's still these steps that get up there. But if you've made it all the way here, and in this example, they've done this several times. There was 1, 2, 3. There was 3, 4 check-ins yesterday. One of them was actually released to production 2 hours ago. There's another one that failed. That was fixed and put it into production. The idea is, we know this software is working because we didn't change very much. It passed our acceptance testings. We're doing a little bit at a time, so we're confident to get it out in production. And that's a very different mindset than let's work on something for a month and then kill ourselves on release night to get it out there. So, of course, to me, that's like the best thing I've ever heard, which is why I'm here. Okay, so long story short. My goal for this presentation was to give people like real actionable steps for how to get this implemented on your own systems, because if you're to do it like by the book, it would take an incredible amount of resources and an incredible amount of time. But I think you can get started on this journey with a couple of really easy steps. The number one, the biggest one you can have is one deployment script for your environments. If you're deploying software into your environments, into tests or production, like automate that. There's no reason that shouldn't be a simple thing to do, right? It should be mindless work. It's copying something and putting it somewhere and starting something, whatever. So you get a lot of documentation out of that. You're going to save yourself a lot of headaches, and you're going to have a repeatable process. Even if you continue to use the same release pattern that you've used for ages, if you've been using this in test for a month and then you finally send it to production, it's still running the same script and the same thing. So it's a huge win, and I think it's probably the best thing you can do. The second best thing, my personal opinion, is practice continuous integration. Get your team to the point where you're releasing things in smaller incremental changes. You're always you're making smaller changes. Those are going through testing. You're working at, all together, and you're not saving the large testing push for the very end of the project when, there's all these different things that need to be tested. Let's do it a little bit at a time, keep everything happy, keep everybody in the same environment, and just, keep working on that one release or that one artifact. Next biggest thing is environment as code. I'm a huge supporter of environment as code or infrastructure as code. I will say though that it requires time, and it requires a specialist. So you have the DevOps movement, people working to improve these things, but it's a lot of work to manage an infrastructure, and Puppet and a lot of these other technologies are not. I mean, despite what the marketing will have you say, it's not super easy. It requires time, it requires energy. But if you can get to that point where you're provisioning environments, boom, it just takes so much guesswork out of getting software out. A self-service dashboard the continuous deployment pipeline is pretty much, thinking about this now, I might even switch around the environment as code and the self-service dashboard, but a consistent place where you're constantly pushing things into your environments and testing them and getting them out there is a huge, it's just a huge one. It's visible, it's loud, it fosters collaboration, it fosters an atmosphere where you're building quality into your product from the very beginning rather than at the very end as an afterthought. And yeah. So if you have any questions offline, feel free to email me. Email me, John at Productive Edge, and I have a personal blog called Large Pixels where I occasionally write about this stuff as well. And that is it. Is there any questions? Let's see.
Yeah.
Question over here.
So what kind of roadblocks do you run into with third parties such as, let's say, in Humana World, you have corporate review, you have business review, you have UX review, all these different external teams wanting to review something before it gets released or even put it in testing environments.
Mm-hmm.
How does that affect trying to get something done as quickly as possible?
Right. So that's the problem everybody faces, right? Is we have this old way that we're trying to do things and everybody's used to it. So I mean, that right there is kind of the crux of the problem. It's the reason for this speech is there's a lot of misunderstanding about what this process is. In my opinion, if you start with continuous integration and you're constantly pushing this stuff out there and you're doing your part, people tend to follow suit. And if you prove that you're committed to this and you're doing these things, and people are a little more willing to get on board. But I mean, you talk to any manager about releasing something into production all the time, it's going to be met with resistance no matter what. I mean, eventually I think that model is going to shift. If you look at the way Facebook's doing things, Amazon's doing things, there's no way it's not going to go to this model in the future. Like, people are need to get stuff out there fast, but we're still kind of dealing with those old paradigms. Even at TVG right now, we are still releasing once a month. It's still the big, scary thing, scary emails. For my team, that's not stopping us from continuously putting software into our testing environments, writing these automation scripts, and then you doing. I like to use the phrase doing your homework, right? Like, we do our homework to show that we're improving this, and people are much more willing to get on board with that. But I will say that is the hardest. That is without a doubt the hardest part about implementing a true continuous delivery. And you also don't have to go overboard with it, right? Like, just implementing a couple things and releasing the software, like, if it's every 3 months, moving to once a month, or moving every week or something like that. That's a huge win. You don't have to go all in. As a matter of fact, I don't think I'd even recommend going all in.
On a similar note, so what's the ideal, in your mind, time frame for continuous development? I think in your earlier slide you said like once a day.
Yeah, that's. I'm a realist, and I personally, that system could work. It takes an incredible amount of discipline to get to that point.
Yeah.
For me, once a week sounds really reasonable. Thursday evening or something like that, putting something out there. I mean, you should be able to get to the point where these deployments are happening so fast that putting something into production should be as simple as, you should be able to do it during the middle of the day, right? Right now everybody gets online late at night or on the weekends, and it's expensive to get everybody online at that time because it takes so long to do something. But if you can just do it, in 2 minutes or something like that with no downtime, if you're clever about it, then it shouldn't really matter. But to me, every other week is reasonable. I have yet to see anybody, period, do it in several times a day. I think Facebook is like that right now. They have engineers who kind of like, they don't really ask for, they from what I read this in an article a long time, Facebook has a system where you want a feature out and you kind of rally the troops and you say, hey, we're going to do this, and somebody is sponsoring it, and they don't need a whole lot of permission to go out and deploy something, right?
Yeah,
right now,
it's a trust-based system.
yeah, it's trust-based. And as a matter of fact, Timo, I think, might be doing a talk on microservice architecture, and that's called lockstep deployments, right? Everybody is doing everything at the same time, where it's like we have this big software release, and it's like, you have all these people who are solving these puzzles, and we take all these puzzles and we push them into production at the same time, right? It doesn't necessarily need to be like that. If you're working on your small part of this infrastructure, why can't you release your small piece without them learning? It kind of breaks everything up, and that's another one of my, like I said before, it's one of my favorite things about continuous delivery is it takes, it's just like this thing that ties together all these brand new practices and the ways people are thinking about things, breaking things down and deploying them and making teams independent of each other and that sort of thing.
Can I keep bugging you?
Yes, please do.
Okay. What about situations where you have to, say you're on a mobile app and you have to go through something like the App Store or Google Play where they want to review everything that you do, and sometimes it takes days to get through that barrier?
Yeah, in the mobile world, you're not going to get around that, right? Because I don't even think you don't even know when they're going to get back to you on it. So,
Right.
For the most part, that's no reason you couldn't practice continuous integration. It's no
You just
reason.
add on that buffer.
You just add on that buffer, but you're still constantly, sending things through those unit tests that you wrote in that environment that's constantly like hammering on your system to prove that it's in a working state. So by the time you get to there and you release it into an environment that looks and test it in an environment that looks so much like your production, it shouldn't be a very big deal to fire that off to the App Store and let them send it through.
When it comes to unit test coverage,
Yeah.
so you mentioned you don't want to do just an arbitrary number, which I totally agree with. But the challenge is how you define what's the what to cover and what not to cover. And so the problem with 80% is you're still not 100%. So you're still leaving some room, some guesswork, right?
Mm-hmm.
Do you have a rule that you go by and say, okay, this is when we should use a unit test and this is when we should? Or is it so subjective that you can't define it?
Honestly, I wish I had a good answer to that because I don't. It also comes down to trust of your developers, right? Confidence. And if I prefer to, if you have smart people on your team, I like to let them use their brains and trust them that they're going to do that sort of stuff. But a lot of that responsibility falls on my head too, to make sure that they're following through with it, and it's my decision if I'm going to say something is okay to release in a production given the unit test that they have on it. As a tech lead, there's no way I can even do coding anymore from now. I can make a full-time job out of just looking at what other developers are doing, and even that I'm still limited. So my capacity to really make sure I have to trust them, otherwise I can't. And you learn over time. I wish I had a good answer to that question because it's a pet peeve of mine, the code coverage thing. But it's just, yeah, I don't know. Maybe I'll read the continuous or the testing book next a little harder.
Let me know what it says.
Yeah.
Well, it's interesting because also, it goes back to that trust-based system that you were talking about earlier, where if you're in a large corporation like Facebook or something, that's really trusting a lot of smaller individual teams to do their own job and
So
have the 8% coverage, be 100% and see those things.
So things break all the time, right? Things break all the time, and if you have this big legacy system with no test coverage on it, it's this thing that nobody likes to touch, nobody likes to restart it. It has weird documentation and all that, and it's like, oh my God, where do you begin? In my personal opinion, something breaks in production, boom, make a story out of it and get that covered right away. To me, that's obvious. You have something that broke, write a test to cover it. That problem is solved for the rest of your life because you took the time to address it. A lot of times we fix something, never bother with it again, break 6 months later. So you could probably cover your system very well just from things that ended up breaking when they're in the environment, and oftentimes that's what I end up doing.
Just a side comment, this whole thing also just enables developers to get set up like so quickly now. If you have your environment scripted, then it's like instead of having to send it to DevOps and spend 3 days installing software, you can run a script and have it up in a couple hours,
And the Vagrant stuff too, or the Docker instances, if you don't have to subscribe to the Docker model, but Vagrant or Docker, you have those things right on your computer. If you're and even very large systems like the one at TVG or other places I've worked, they're distributed, so they might have 10 machines that are just serving web content and 5 of them that are balancing a database. Your machine can handle bringing up a single instance of all of those machines, usually fairly easy. So you can recreate an entire environment on your machine just at the push of a button. I have a personal project. I built a web crawler, and that, since I'm the only one operating in it, my development area is exactly like my production area, right? Same, this is a personal project, so the same username and passwords everywhere, but it's exactly the same thing. It doesn't matter where it is. I can run the same script and even so much as the Git repo is the same thing, or the configuration management server. I mean, you could think of a configuration management server as this thing that lives outside of your infrastructure, but it could also be something that lives inside your infrastructure. So even making changes to the configuration management server could be something that's automated and something that gets tested before you release into production. Which Puppet, when I started with it, they didn't really have a good way to solve multiple environments, but now they do. And it is the model where it exists outside of it, but there's no reason even your email server or whatever else you depend on couldn't be set up with your environment.
How does Puppet use? So what I saw was setting up accounts. How does it set up like the password piece, authentication piece? Does that go to the
Yeah.
server
So well, it depends on what you're using. If you're using LDAP or something like that, or if you're using local authentication on those machines, but essentially. Puppet allows you to write modules for it, just like most of these configuration management systems allow you to write a module. And back on my old slide, there was the user module, and I wrote that before like a Puppet user module existed. But what that did was created all the same users on the system. So if I included that, it would include John, and it would include the sysadmin account and all these different accounts that I would use, and you can configure that to use the same SSH key. You can configure it to use multiple SSH keys. You can configure it to use certain SSH keys for certain environments, right? There are ways to lock that down, but if you wanted those automatically set up, it's possible as well. And that's the thing about Puppet is it also a lot of these configuration management allows you to it does account for the fact that there are going to be differences in your environments. It's not one thing that's going to do it all. It inherits from this one thing that everybody's going to need. And then based on how you define yourself, if my host name says developer 05, right, that's a developer machine connecting to me to want to be provisioned, and I know that they're probably going to need, the JDK installed on their machine or other libraries that maybe aren't necessarily needed for production, things like that. All right. Are there any questions on the phone? I will take that as a no.
Thanks.
All right. Thanks, everybody.